Hello, my dear students. Good day to each one of you. So we are here once again for another interesting discussion in relation to what we have already shared in our previous encounter all about the spherical mirrors. But for this encounter, we are going to focus more on the image formations for concave mirrors. So if you are watching this video right now, just sit back, relax, and enjoy some moment of science with me. In the previous discussion that we had, we talked about the different kinds of curved mirrors, and we have already identified them as concave and convex mirrors. We also discussed about the different image formations in concave and convex mirrors. Now, for this encounter, we will focus more on the image formations by concave mirrors because unlike convex mirrors tend to have the same characteristics of image wherever you place the object in front of it. And that is always virtual, and it is always smaller than the object, and it's upright. Unlike concave mirrors, the image characteristics depend mainly on where you put or place the object in front of the mirror. So, let us now begin our discussion about the image formations in concave mirrors. So, we will be talking about the 5 scenarios for each type of concave mirror image or object position rather. So, first, we will have the object that is found beyond C. Then we will also talk about the object between F and C. Next is object exactly at the center of curvature. And then object at F. And last but not the least, object that is in front of the focus or focal point of the mirror. And to do this, later, we are going to visit this virtual laboratory link. So if you are already watching this video, you can actually visit this link that you see on your screen right now. Let me just move my camera so that you can see the complete link. There. Visit that link so that you can follow through it. But actually, this link is also found in your learning modules. So you just need to go over to your learning modules and click on the link that you find there. And that will lead you to the link for the virtual laboratory. Now, before we move on to the virtual laboratory itself, let's first illustrate this. Let's illustrate each scenario. Now, for number 1, that is object beyond C. And of course, for number 2, this object at point C. And for number 3, we have object at between F and C. And for number 4, we have object at F. And lastly, number 5, we have object that is in front of F. So this is how our object position will look like later during our virtual laboratory. So let me now move on to our virtual laboratory. So this is how your virtual laboratory will look like. So, okay, there. So I already set it up so that you can already navigate, or we can already navigate this one. This is the object right now. Okay, so the ones that you are seeing right now on your screen is the object, and of course this is a concave mirror. What we are just going to do is just drag this object wherever we want it to be placed in front of our concave mirror. So let us now start with object that is beyond the center of curvature. Okay, now what do you notice? Now as you place the object beyond the center of curvature, wherein it is labeled as 2F in this case, so don't confuse yourselves, because the center of curvature is twice the length of the distance from the focus of your mirror. Okay, so what do you notice about the image here? Now the image that is formed is this inverted arrow that you see right now. Okay, now let's describe this image using the lost method, where L stands for location. Now, where is the image located? Now, relative to the positions of F and 2F or C, you can say that the image is found actually in between the F and the 2F or C of your concave mirror. So that's how we describe the location of this image. Now, how about its orientation? As you can see, the intersection of all reflected light rays are happening below the principal axis. So that means that you expect to see an inverted image. Okay? So that is actually an inverted image. Now, how about the size of the image itself? Now, just by checking or observing the relative sizes of the upward arrow or the object's arrow and the image arrow, you can already see that the image is actually smaller than the object. But to verify that, just look at these parameters on the lower right side of your screen, wherein you can see that the object height is 21 centimeters, but the image height is only 9.9 centimeters. So that is how we describe this image that is formed when the object is placed beyond the center of curvature of your mirror. Now, let's move on and try to drag this object right now exactly at point 2F or C of your mirror. Okay? I cannot really place this exactly at that point. It's because my cursor is actually shaking right now. Okay? There, but I would like to get it as close as I can. Okay, I believe I already got it. Okay. Now, what you see right now is that the object's location is now found exactly at point 2F of your mirror. But how about its orientation? Once again, all the reflected light rays are happening below the principal axis. So, the image is still an inverted one. Okay? But, how about its size? There. Now, the sizes are not so much of a big difference. You can see in the parameter there, 21 centimeters versus 20.9 centimeters. So, we can say that the objects and image size is identical with each other or the same. So that is how we actually describe the image size in this case. But how about the type of image? Now, of course, we know that if the image is inverted, then we expect that it is a real image. So let's move on and drag this arrow right now and see to it that it's midway between F and 2F of your mirror. Now, what you see right now is a little bit interesting, right? Because the image, as you can see right now, the location is beyond 2F or the center of your curvature. But the orientation is still inverted because the intersection of light rays is still happening below the principal axis. But the size is now getting bigger, right? And of course, since it's an inverted image, it is still a real image. Now, if I place it exactly at point F, you will see that there is no intersection happening in this case. So what does this imply? Well, it only tells you that there is no image formation in this case. It's because when light rays are reflected, they tend to be parallel with each other when the object is found at the focus of your mirror. So that's the characteristic of the image if you place the object at exactly the focus. Now, let's go to the last case. Let's place the object exactly at point F, in front of the focus of your mirror. Now, it's a very wonderful thing to watch, no? Because right now, you can see that the image is now streamed at the back of your mirror. So, the image location is behind the mirror in this case. But how about its orientation? Now, it is different because you can see that the intersection of light rays are happening above the principal axis. So, we can say that the image is now an upright or erect image. How about its size? Well, it's very obvious. The arrows' relative sizes are different. The image now is getting bigger than the object. And how about its type? And since it is an upright image, then of course, this is a virtual image. And that actually completes our image descriptions for each of cases in the concave mirror. So you can actually play it around here like that, right? So when you observe this in front of a concave mirror, it's actually a very fun thing to watch. So that completes our description for concave mirror image characteristic. Now, to summarize everything, class, let's go back to our PowerPoint presentation. Now, for object that is beyond C, the description is always between F and C, inverted image, a reduced one, and of course a real image. But if it's object exactly at point C, the image is exactly at point C also, it is inverted, of the same size as the object, and real. And for objects between F and C, its image is beyond the center of curvature. It is still inverted, enlarged, and this time it's still a real image. And for object at F, no image formation at all. And for case number 5, object in front of F, you expect to see an image behind the mirror, an upright one. Of course, it's enlarged and it's virtual. And that actually completes our image description for objects placed in front of a concave mirror. So how do we describe this in general? Image formations in concave mirrors depend on where the object is placed in front. The image can be real or inverted, it can be virtual or upright, and it could be enlarged or it could be reduced or equal in size as that of the object. So the image characteristics varies with the object's distance from the mirror. And that completes our descriptions of images formed by concave mirrors. And I hope that you have learned something out from our very simple demonstration on the image formations by concave mirrors. So, this is our goodbye already. So, thank you so much for listening for our discussion for today's lesson. And I hope that you have learned something from this encounter. And if you want to share this knowledge to everyone, you can share this one to your friends, to your families, for those who are studying about different image formations in concave mirrors. So if they're having difficulties of that lesson, then you can suggest this video for them to watch so that they can understand the topic well. So this is once again Mr. Rabino, your science teacher, saying you have spread love, you have to spread love, spread science, spread knowledge. So goodbye everyone, and see you once again for our next encounter. Bye!